Hello engineers, welcome back. In this video, we're going to start a new topic, which is the greedy method. I hope you're ready. Let's get started. So in this video, we're going to look at some terminology to better understand the greedy method. After knowing this terminology, we will look at how greedy method works and we will see some examples. Okay, so let's get started. So for the first thing we need to know is greedy method or the greedy technique is used to solve optimization related problems. So what do we mean by optimization? Let's try to understand this with an example. So let's say I want to go from a place A to place B. So if we use Google Maps, we can see that for every search destination, we are given different routes and one optimal route is chosen, right? So if I'm going from location A to location B, there can be multiple paths I can take. I can probably take a bus. I can probably take a train. I can probably go on my car and so on. So all these are different ways to reach B, right? But what is the best way to go from A to B? So all these are possible ways to reach B. So these are feasible solutions. Okay. So whatever method we are taking to go from our target to our destination are all feasible solutions. There can be other solution as well, right? I can go on bike. I can probably walk there. There can be many solutions. But what is the best solution? Best solution is something we will define or it will be given in the question. So for example, the question might say choose the shortest time. So in order to pick a solution according to this criteria, I want to travel in the shortest time. Then I will probably take a train, let's say, for example. This will give me the shortest time. Another criteria can be shortest distance. Okay, shortest distance. That way, I will probably use my car because I can take some shortcuts or something like this, and I will probably reach my destination in a shortest distance. Okay, that way, depending on the criteria, I'm able to change my strategy of traveling from A to B. So the options that take me there are feasible solutions. The one that gives me the best criteria is my optimal solution. Okay, so in any optimization related problem, we are either asked to calculate a minimum number of something, let's say minimum distance or minimum number of steps to be taken, or it can also be uh, maximum profit, or we can say things like maximum items. So whatever is the criteria, we will have some feasible solutions. Among those feasible solutions, we will choose one optimal solution based on that. Okay. Now these are optimization related questions or situations. So what is greedy method? Greedy method is one such technique which can be used to solve optimization problems. So if you see a question asking for minimum something or maximum something, you can categorize that question as a optimization question. And one of the solutions can be obtained through greedy method. Okay. So how does this look like? So the best example to understand greedy method is the coin change problem. So let's say I have the notes or currency denominations like this: 5 rupee coin, 2 rupee coin, 1 rupee coin, 10 rupee coin. I have such denominations. Now I want to create the amount of, let's say, 35 rupees. Now, how do I make 35 rupees from these denominations? So I can do 35 coins using 1 rupee coins. I can take 35 of them and make 35 rupees. or I can take 7 5 rupee coins. 7 into 5 will give me 35. Or I can also take 3 10 rupee coins and 1 5 rupee coin. This will also give me 35. So there can be multiple combinations like this, right? But what is the best combination? To get the best combination, we need to find the criteria. The criteria is minimum coins. Minimum coins, use minimum coins to get to 35 rupees using these denominations. So this minimum coins or maximum profit or maximum items, this is called criteria, or we can say constraint. So how do we get minimum coins? So the approach is like this. You sort the denominations in descending order. In this case, they're already sorted. If they were not sorted, you sort them first and pick the maximum coin first. Maximum denomination first. And check. So let's say I'm picking the maximum denomination of 10 rupees. I need to make 35 rupees, right? So I picked one coin which is 10 rupees. So how much is remaining? 25 rupees. So I will check again. Can I take another 10 rupees? Yes, I can take. Now how much is remaining? 15 rupees. Can I take another 10 rupees? Yes, I can take another 10. How much amount is left? Now only 5 rupees is left. Now can I take another 10 rupees? No. So we will not use 10 anymore. We will look at the next best available coin. So that is 5 rupees. Can I take 5 rupees? Yes, I can take 5 rupees. Now I have reached 0. So when I have reached 0, I will stop. So how many coins are there? 1, 2, 3, 4. There are 4 coins. Okay. So in 4 coins, I am able to obtain my destination, which is 35 rupees. And I have followed the constraint that I need to do that in minimum number of coins, right? So this is how greedy method looks like. Among the multiple solutions, how do we use the constraint given to us to obtain the target? So that is how greedy method looks like. Okay, so let's try to code this in our C++. Okay. Okay, let's begin by declaring our vector where we store the denominations. This will be an int vector. It will store denominations. Let's add some denominations to it. For our simplicity, I am pushing them in the decreasing order. We can have denomination of 10, 5, 2, and 1 rupee coins. And our target amount is 35 rupees. Now what do? We need to iterate over each denomination from largest to smallest and then see if we can pick that coin, right? So when do we pick a coin? When do I pick the 10 rupee coin? When 10 is less than 35, then I am able to pick 10 rupee coin, right? And I will reduce the amount. The remaining amount will be 25. Again, I will check. Can I still pick a 10 rupee coin? Is 10 less than 25? Yes. So again, I'll pick another 10 rupee coin and I will continue this process. Okay, let's see how that will look like. So let's iterate over the denominations vector. I equal to 0, I less than denominations dot size, I plus plus. So as long as the current coin is less than the given amount, I can continue using it, right? While denominations of I, current coin is less than equal to amount, right? So amount is 35. Now denominations of I is carrying the number 10 if I is 0, so we can pick that coin. So what do we mean by picking it? So I will reduce 10 rupees from my main amount. So I have reduced 10 rupees. I will continue this loop until this condition is satisfied. So I will keep picking 10 rupee coins. Okay. So in order to know how many coins we have used, let's keep a tracker. Let's call it coins. Initially there are 0 coins. As soon as we have used a coin, we will do coins plus plus. Okay. Let's do one more thing. Let's create another vector where we store the coin that is used. So vector of int, we can call it coins used. And as soon as I use a coin, I will push it to this vector. So I'm pushing the used coin here. Now, what is my exit condition? Exit condition is simple. When there is no more amount to be given, I can come out of the loop. If amount is less than or equal to 0, then break. So how does this work? First, I am at I equal to 0. I am checking whatever is in 0th position. 0th position has the value 10. Is 10 less than the amount, target amount? Yes. Then reduce it from the amount and add it to my coins used. Now my amount has become 25. I am still in the inner while loop. Now again I will check, is my denominations of I, which is 10 rupees, is it less than 25? Yes. So I will use it. Coins will now become 2. It was 1 before, now it will become 2. And coins used will have 2 10 rupee coins. I will again repeat this process. Now 25 became 15. I can still use a 10 rupee coin. So coins will become 3 and third 10 rupee coin will be added here. Now the amount is 5. Now I can no longer use this 10 rupee coin. I will come out of this inner while loop and amount is still 15. So this if condition is false. So I will come out of the main for loop and I plus plus. Now I is here. Now we are looking for 5 rupee coins. Is 5 less than the current amount, less than or equal to, right? So I can still make a 5 rupee coin. So 5 rupee coin, yes, I can use it. So I will add it to my coins. So 4 coins are used and 5 rupee coin is added here. Now my amount becomes 0. So I will come out of, I will go inside this if condition and I will come out of all loops. Now we can simply print the way we want. Let's see, we can print coins. We can also print the coins used. For this, we will iterate over the coins used vector. Cout coins used of I, and we will give some space, and that's it. So let's run it and see. So these are comments. Let's remove these comments. So we can see 4 coins are used and we have used 10 rupee coins 3 times and 1 5 rupee coin. So our code is working fine. Okay. So this is how we can use the greedy method. So let's recap what we have just done. So in the greedy method, there is an input array and there is a given criteria or a constraint, and we need to come up with the greedy criteria. In our coin change problem, the greedy criteria we came up with is like this. Use the highest denomination first. Use the highest denomination first. And as soon as you are done using it, then go for the next highest denomination. So that is the criteria. So coming up with this criteria is the crux of the greedy method. If you have this criteria, you have more or less solved the problem. So we will try to understand how to come up with the greedy criteria using different examples. So for this video, let's pause here. This is like an introduction to greedy method. In the next videos, we will go deeper into this subject. Okay. Thank you so much for watching, guys. I hope it was helpful for you. If you have any questions, please definitely ask me. I know greedy method is a little bit confusing. It was confusing for me as well. So let's be patient and let's try to understand it using different examples. Okay. Thank you so much for watching. I will see you in the next one. Thank you. Cheers.